Okay, this video is going to be about finding the value for a in the AHK form of different functions. Okay, so finding the value of a can be really easy if we have a really nice little graph, and especially if it's on grid paper, or you can see the grid lines behind it. If you can find, basically what you really need to be able to find is find the special point. So for parabola, you need to be able to see the turning point. For a cubic function, you need to be able to see the point of inflection. For a square root function, you need to be able to see where it starts, etc. Another name for these points is the stationary point, and sometimes we might call them the special points of the function. Okay, so if you can see the special point for your function, you can see h and k. So that's the first bit. Easy. Most of us are all really confident being able to do that. However, a can be the tricky bit. If you have a piece of graph paper, you can see one step to the side and how far up that is. That means that you can find a, because remember, in all functions, in order to find that first step across, we step across 1 and up a. Okay, so if you've got graph paper and you can see that, very easy. However, if you just were given some values of a function, just say that you knew where a function started and another point that it crossed through, or the turning point and one of the intercept points, you're not necessarily going to be able to see the a value straight away, and you have to solve it algebraically. It's a pretty easy process to solve algebraically. You just need to substitute everything in. So let's give it a go with a cubic function to start with. Now I'm just going to pick any old cubic function. In all likelihood, it's going to be a bit nasty. Bit of a nasty value. Oh, we don't want the equation. What we want is we want the point. So let's have the points of inflection. The points of inflection being 3 and minus 2. And it crosses through another point at, I don't know, 5, 3. Okay, so if we were to draw that, it's a cubic function. 1, 2, 3, 4, 5. 1, 2, 1, 2, 3. Oh. Okay, so minus 3 and minus 2. That's the point of inflection. Then we cross at 5 and 3, so it's up there. So our cubic function is going to be doing something like that. It's not a perfect sketch, just an idea of what's going on. Okay, so we definitely can't see the a value because the point that we know about is 2 steps across. Okay, so we can't see the a value. We can only see the a value if we can see across 1 step and how far up the function goes. So basically we write down what we can see of the function. I know h is my x value of the point of inflection, and I know k, which is the y value of the point of inflection, and I also know the general form. I know this is a cubic function, so I can go, well, it's definitely y equals a x minus h cubed plus k. That's all the things that we know about. Then we fill it in, so we go y equals a x minus 3 cubed minus 2. Okay, and then all we do is we use the point that we know about and we substitute that in. So we're going to say 3 is equal to a 5 minus 3 cubed minus 2, and then all we have to do is rearrange it to find a, and we can find that value. So let's see what we get. Plus 2 to both sides, we get 5 equals a 5 minus 3 is 2 cubed. So 5 equals 8a, so therefore a equals 5 over 8. So yeah, fairly nasty value. We wouldn't probably have been able to see that on our own, but solving algebraically is pretty easy. Okay, so there's that function. This works the same for a parabola, it works the same for a square root function. It really doesn't matter. Let's try a square root function. Let's try square root function that has a starting point of I was just doing a nice one. Let's just make one up. Okay, starting point of 4 and 3, and a y-intercept of 5. So if I just do a quick sketch of that, you can see that I've got here we go. So 1, 2, 3, 4, 1, 2, 3. So it's going to be doing something like this. Not a perfect sketch, but it's a good idea. Now, looking at this, remember square roots have different forms. This is a square root that goes to the left, so I know I must be in the y equals a square root of h minus x form. Okay, so just like with that cubic function, we write down exactly what we know. Let's figure it out. I know my h must be 4, my k must be 3, so therefore we've got y equals a 4 minus x plus 3, and then we just substitute our extra value in. We know the value 0, 5, so I'm going to substitute that in. So I'm going to say 5 equals a square root of 4 minus 0 plus 3. Subtract the 3 from both sides. A times the square root of 4. So 2 equals a times by 2. So therefore a equals 1. So in this case, a is a really nice value. We just wouldn't have been able to see it from the graph. Okay, because on that graph I didn't have any grid paper, so I can't see that my step to the cross of 1 also gives me a step up of 1. Okay, so therefore my final function is y equals 1 square root of 4 minus x plus 3. Okay, hope this helps in you finding your a values in your AH and K form.